Imagine that everything you think or believe about the universe is wrong, that the rules we learned about how galaxies form, about when life can emerge, about what's possible out there, were just assumptions based on limited data. And now, in 2025, we're no longer guessing. We're measuring. We're confirming. And what we've found is turning our understanding of the cosmos upside down. In recent months, 3 revolutionary discoveries have forced the scientific community to rewrite astronomy textbooks. And I'm not talking about theories or speculations. I'm talking about concrete evidence that has reached us through the most advanced telescope ever built by humanity. The first discovery takes us to the beginning of time, when the universe was only 280 million years old. An era when, according to our models, there should have existed only cosmic chaos. But what we found there challenges everything we thought we knew about how the universe evolved. The second brings us closer to home, just 124 light-years away, where we detected something in a planet's atmosphere that, on Earth, comes from only one source: life. And we're not talking about weak signals. We're talking about concentrations 1,000 times greater than what we find here. And the third discovery is so close you can see it in the night sky. But it still held secrets we've only now managed to unravel. Let's start with a journey to the most distant past we've ever been able to observe. In May 2025, the Webb Telescope identified a galaxy called JADES GS-Z14-0. This might sound like just another complicated scientific name, but this galaxy represents something extraordinary. The light we're seeing today left there when the universe was only 280 million years old. To put this in perspective, if the universe's history were compressed into 1 year, we'd be looking at something that existed on January 10th. The universe had just been born on January 1st and should still have been in its first chaotic moments. But here's the problem. This galaxy doesn't look chaotic. It's compact, organized, about 500 light-years in diameter, with a mass of approximately 100 million suns. It's like finding a fully constructed city in the middle of a construction site before the foundation has even been laid. According to everything we knew about galactic formation, there simply wasn't enough time for this to happen. Galaxies don't appear instantly. They need time for gas to cool, for stars to form and cluster together, for gravity to sculpt their structures. The appearance of a mature-looking galaxy so early throws a wrench into this entire understanding. And JADES isn't alone. Webb has been stacking up discoveries like this for over a year. Galaxies that are too old, too bright, too large for the era they exist in. Each new observation pushes our timeline a little further back and forces us to reconsider how quickly the early universe was evolving. Some scientists now propose that the first stars formed more rapidly than we expected. Others think dark matter may have played a more active role in organizing matter early on. And there are more radical ideas, that perhaps the physics of the early universe weren't the same as today, that maybe time itself moved differently, or gravity functioned in slightly altered ways before settling into what we experience now. We don't have the answers yet, but JADES is a huge clue. And it's not just a pretty picture of a distant galaxy, it's a direct challenge to how we've explained the universe's first chapters. While JADES raises questions about when the universe began to function, there's something much closer to home that's forcing us to ask a very different question. Not about when things started, but whether something out there is already alive. Not imagined, not theoretical, not someday in the future, right now. That planet is K2-18b. It's about 124 light-years from here, and for a long time, it didn't stand out. Just another exoplanet orbiting a small, quiet red dwarf. It was interesting because it sat in the habitable zone, the region where conditions might allow liquid water. But beyond that, There wasn't much excitement. Too big to be Earth-like, too strange to make headlines. But then Webb looked at it and, in its atmosphere, caught something that changed everything. A signal that on Earth usually points to life. That signal was dimethyl sulfide, reported in a study published in January 2025. If you've ever been near the ocean and smelled that strong, salty scent of sea air, you've smelled this before. It's dimethyl sulfide. On Earth, it's released almost entirely by small marine organisms when they die and decompose. This gas rises from the ocean into the air. It doesn't last long. Sunlight and oxygen destroy it quickly. So for it to remain in the atmosphere, it has to be constantly replenished by life. When Webb caught traces of this gas in K2-18b's skies, scientists didn't jump to conclusions. At least, not publicly. There's always a long list of things that can go wrong. Incorrect readings, overlapping signals, or some strange chemical process we just don't understand yet. So they checked again. And the second time, the signal didn't just appear again, it came back stronger. Not only was dimethyl sulfide still there, but its concentration was estimated at 1,000 times higher than what we find in Earth's own atmosphere. This isn't a small signal. This isn't a fluke. It's something pumping out gas on a massive scale. On Earth, there's no known way to put dimethyl sulfide into the air at these levels without something living doing it. That doesn't mean it's impossible otherwise, but right now we don't have a better answer. And remember, this is a planet with a thick, hydrogen-rich atmosphere covered by a deep global ocean. If life exists there, it probably isn't like anything we know. It could be microbial, small organisms floating in the sea, chemically reacting to the environment. But if the signal is this strong, maybe we're not talking about just a few scattered microbes. Maybe we're talking about an entire ecosystem, a living, breathing ocean planet. Of course, there are still steps before anyone can say this out loud. The data needs to be confirmed again, ideally by other instruments, by other teams. More observations might clarify whether K2-18b's dimethyl sulfide is a sign of alien life or a chemical false alarm. For now, it's an exciting clue. Even so, we'll need to rule out all other possible explanations: chemistry, geology, atmospheric physics. But if nothing else fits and the signal holds up, then this is no longer theory. This is evidence, real, measurable, testable evidence. After looking so far that we're literally staring at the beginning of time, it's easy to forget how much we still don't understand about places right next door. That's why it caught people by surprise when Webb turned its attention to Neptune. You wouldn't expect a deep space observatory, built to peek at the oldest galaxies, to be looking at planets in our own solar system. But that's exactly what it did. And what it found wasn't just more details. It was a reminder that even the familiar is still full of unknowns. Neptune is the most distant major planet in our system, dark, icy, and rarely in the spotlight. Most of what we know about it comes from just one close encounter, Voyager 2, in 1989. Since then, it's been studied mainly from a distance, through blurry ground-based observations and passing glances from space telescopes. When Webb finally pointed its mirror in that direction, it was the clearest view we'd ever had. And immediately, something stood out: the auroras. These aren't like Earth's northern lights. Neptune's auroras are different, less studied, less predictable, and much harder to observe. But Webb, with its infrared vision and ultra-sensitive instruments, caught a complex, swirling light show at the planet's poles. It wasn't just visual, it was data, detailed maps of temperature, changes in atmospheric chemistry, signs of powerful magnetic interactions happening at the cold edge of the solar system. Webb's observations revealed temperature variations in Neptune's atmosphere that aren't fully explained by sunlight alone. In some areas, the planet was cooling unexpectedly fast. In others, strange heat signatures suggested internal activity or even unknown chemical reactions in the upper atmosphere. These aren't just curiosities. They're clues about how magnetic fields work, about how energy moves through planetary atmospheres, and about how space weather behaves at the outer edges of a stellar system. It's easy to get lost in the individual discoveries. One planet shows signs of a strange gas. One galaxy appears earlier than it should. One world looks like ours at a time before we imagined that was possible. Each of them seems big on its own. But the real change, the part that's hardest to see unless you're paying attention, isn't in the details. It's in the pattern. One by one, the universe is answering questions we barely knew how to ask. Not with anything loud or dramatic, just with data. Quiet, clear signals telling us that the silence we thought existed out there was never really silence. We just weren't listening the right way. That's what's changed. The difference now isn't that we're suddenly surrounded by answers. It's that we've finally built a tool precise, sensitive, and stable enough to listen, to really listen. Not for vague signals, not for science fiction dreams, but for real physical signs that the universe has always been full of motion, full of structure, and maybe full of life. JADES forces us to redraw the initial timeline of galactic formation. K2-18b suggests we might already be watching something breathe in a distant ocean. And Neptune, our own planetary neighbor, still has surprises we hadn't even looked for until now. But the bigger truth isn't about any of these individually. It's about what they all mean together. Because now we know the universe didn't wait for us to understand it. It wasn't silent, and it wasn't empty. It's been full of complexity from the beginning. It's been forming galaxies faster than we expected, building systems more stable than we assumed, and possibly allowing life to emerge much earlier than we thought conditions were right. We've always wondered if we're alone. It's one of the oldest questions we've asked ourselves. But maybe we were never really alone. Maybe we were just blind. And now, finally, we're starting to see. Not everything, not clearly, but enough to know that something is out there. And for the first time in history, we're not just imagining, we're measuring. Click now, like this video if it made you rethink our position in the cosmos, and subscribe to the channel so you don't miss the next discoveries that are redefining our reality. Until the next journey into the unknown, goodbye.